All right, this is for chapter 11, just as a review. So here are some common indices of refraction. Of course, for a vacuum, it's one. For air, it's practically one. We usually just, define it as one. And then, think things like water is 1.33. Let's see, there's some common ones. Um, uh, Crown glass is usually about 1.5. It could be it could be up, depending on the manufacturer. It could, or the substances manufactured with, could be up to 1.54. All right, so let's see some other stuff. Polycarbonate 1.6. Some of this is not as all right, diamonds. It's 2.417 and so forth, right? So there's silicon, um, and so forth. The benzene, a little more than 1.5. So these are just some common things some common um, compounds that have an index of refraction, or just given what the index of refraction is. All right, so here we're gonna do some examples. Actually, let's look at this. All right, so this is what I wanted to cover here. Um, so the index of refraction, which is given the symbol n, is a measurement of how much light, and I put it in quotation marks here, slows down. Remember, light never actually slows down. It always travels at 3 times 10 to the 8th meters per second. But as the light goes through different materials with a different index of refraction, which is what n is, the light appears to slow down for all intents and purposes. What's happening is the light is being absorbed by the electrons in the outer, the outer shells of the atom. It's the electrons absorb the energy, they re-emit the energy, they absorb the energy, they re-emit the energy. And so that process takes time. And so the light appears to slow down. All right. So V is the velocity of light in the medium, and N is this thing called the index of refraction. All right. So we'll do some examples with that in just a moment. All right. And I also wanted to include, all right, so besides the index of refraction, the only other mathematical thing that we're going to have is Snell's law, which of course we had in lab, or if you haven't had the lab yet, you will have in lab. All right, so Snell's law just says n1 times the sine of theta 1 is equal to n2 times the sine of theta 2. All right, it actually is much easier to look at a picture with that, and here we go. All right, so let me move this over a little bit so we can see it. So here, this is just Googling Snell's law, and so N1, N1 is whatever the medium is. You have these different mediums, and N1 would be this medium up here. So the speed of light is going to be greater up here than in here. Like this would be like going from air to water or something like that. And so the one thing that you got to remember is it's the angle here, like this thing called theta 1, is in medium, in this medium up here, but it's always between the normal. So there's a straight line, a straight line that's perpendicular to the surface, right? So here's the surface right here between medium 1 and medium 2, and here, let me see if I can let me get a better picture of this. All right, so here's a bit. Look at this one with the yellow and the blue, right? So there's a nice picture. This is the normal. This dotted line right here is the normal. It's perpendicular to the surface, and so you have some a ray of light coming in, and it makes an angle theta 1, It's 1 because that's the medium up here. Let's say this is air, for example, and this down here would be water. I mean, it doesn't have to be those two, but that would be a good example. And then so the light comes in at some angle θ1 with respect to the normal, and then it passes into the next medium, which let's say was water, and then because the air is slowed down in water, the index of refraction is higher. If this was air, it would be n is equal to 1. If this was water, it would be n is equal to 1.333. And so what happens, of course, is the light bends towards the normal right here. So and of course it works exactly the opposite. If light is coming out of the water and going into the air, the light would bend away from the normal. All right, so if you were up here in the air and you were looking, this is the example that they use with the fish, for example. If you extend this dotted line into the water, it looks as though the fish was up here, but it's really a little bit further below, right? So like if you're spear fishing or something like that, it's good to know that kind of thing. All right, so let's get back to the examples. All right, so let's do this example right here. Suppose we had an index of refraction of 1.5. That's really close to glass, or some type of glass. We want to find the velocity of light in the glass. All right, so remember the light once again. The light never really slows down. It's just it effectively slows down because it's being absorbed and re-emitted, absorbed and re-emitted. All right, so anyhow, the equation that we have is the n, the index of refraction, which is a unitless number, is equal to the speed of light in a vacuum, which is 3 times 10 to the 8th meters per second, right? That's this number right here, 3 times 10 to the 8th meters per second. And you rearrange the equation and you solve for v, and so the n goes in the denominator, and so it's just 3 times 10 to the 8th divided by 1.5. All right, and so let's look at that, and then we're gonna round it to one place past the decimal, and we will enter that into our we'll put it in scientific notation just like we would do in Blackboard. All right, so here's my calculator. All right, so 3 times 10 to the 8th divided by 1.5 divided by 1.5. And so this is going to be our speed of light in the material that has an index of refraction of 1.5. All right, so the speed of light is that. All right, so this would be, well, it's going to be 2.0. And so remember, the decimal point is implied. It's right here. So I move it, 1, 2, 3, 1, 2, 3, and then 1, 2. So the answer would be, this is how we would enter this in Blackboard. This would be 2.0 times 10 to the 8th. All right. So here, this is what I would do. This would be 2.0 E8. Remember, you just enter that in. You don't put, in Blackboard, it would say how many meters per second this would be. And you don't ever enter in, the units. It always just asks you what it asks you what the value is in a certain number of units. All right. So 2.0 times 10 to the 8th, right? And that's, E8 is how you'd enter it into Blackboard. All right. Let's try another problem. All right, keep in mind, the speed of light is always the same. All right, so here's our next problem. So what is the index of refraction? N is equal to question mark if the velocity is measured to be 2.3 times 10 to the 8th meters per second. Remember, the velocity is always going to be smaller than 3 times 10 to the 8th. All right, and so this is just here's the equation. N is equal to the speed of light, c, divided by the velocity in the material. Notice the 3 times 10 to the 8th. Notice the meters per second cancel in the numerator, right? This cancels and this cancels. And also, just to let you know, the times 10 to the 8th cancels as well, right? Both of those cancel. They're, and so it's really just 3 divided by 2.3. Uh, 3 divided by 2.3. All right, so here let's get my calculator out here. Here, let's get that out of there. All right, so 3, I should have already done this, divided by 2.3. All right, and so the index of refraction, for this one, if we rounded it to one place past the decimal, in Blackboard, you just enter 1.3. All right, so, it would say rounded to one place past the decimal, so this would be 1.3. All right, so there's another problem. All right, so here's a Snell's law problem. So we have light. It's incident upon a medium. So it's going from N1, which happens to be 1. Let's assume that that's air. And it's going into I don't know. Maybe this is glass of some type, plexiglass or something like that. Anyhow, the numbers are all that's important. So N2 is 1.4. Let's say that this angle right here, the incident angle, is measured to be, and so this is theta 1, right? So this is what we call theta 1. So theta 1 is 30 degrees. What is theta 2? All right, so this is Snell's law right here. That's just the general form of it. And now we put our numbers in. N1 is 1. So it's going to be the sine of 30 degrees, which is equal to 1.4, which is N2, times the sine of theta 2. So we got to get theta 2 out of this. All right, so the very first thing to do is make sure that your calculator is in degree mode. All right, so here, let's get my. All right, so here, I just actually completed the problem. I'll go through the steps again. Anyhow, the angle, if we rounded it to 2 places past the decimal, it would be 20.92 degrees. All right, so let me go through and just show you how to do that. Again, make sure you're in degree mode. This calculator is, you can always tell you're in degree mode if you take the sine of 30 degrees. All right, so 30, take the sine, so that's this trig function there. There we go. And so the sine of 30 is 0.5. All right, anyhow, 0.5 divided by 1.4 divided by 1.4. All right, so that's, so we have to take what's called the arc sine of this this fraction, which turns out to be 0.357. All right, so the arc sine of that, if I go to my trig functions and I hit second and see it comes up sine to the -1. That's what this is down here, sine to the -1. And so I just take the sine of the -1 of that number right there. That small fraction is, and so that's how you get the angle. See, that's the angle right there. So when it refracts, when the light came in at 30 degrees, it's going through the material at 20.92 degrees. All right, so that's what we'd put in for theta 2. All right, so this would be 20.92. And of course, it's degrees. I mean, you don't put the degree thing in Blackboard, but of course, that would be theta 2. That's theta 2. All right, so that's a good example. Just make sure again your calculator is in degree mode. That's really important because calculators will normally come up in radian, especially the Texas Instrument ones. So once again, and some calculators, by the way, you have to you hit the sine first. This one is this is a computer calculator. You got to hit the angle first. So 30, and then the sine of 30 is always 0.5. That's just what it is. That's the sine of 30 is 0.5. If you get some other number when you take the sine of 30, then you're not in degree mode. All right, so make sure that if you need to, come to my office hours, and I can definitely just look at you, bring your calculator, of course, and I can always help you figure out how to get to degree mode. All right, that's really important. and then, figure out where the arc sign is on your calculator. It's usually this little